This is a piece of material that isn't in the book, and we're trying to figure out, or I'm trying to figure out, what's the right place to put it in there. But it's another useful design pattern that I wanted to give some airtime to, even if there isn't a book section about it. A very common use case is when you have a component that can be thought of both as an individual thing or as an aggregate of those things. And there are some operations that make sense whether you're talking about an individual member of the collection or the entire collection. So for example, I can say that if I have different kinds of tickets in my system, I can have regular VIP tickets and subscriptions. Well, what's a subscription? A subscription is a bunch of tickets that come as a package, right? Like I buy all of them at once up front and I save some money. So whereas a regular ticket and a VIP ticket are each a single thing, a subscription is really an aggregate of those things. Nonetheless, just like individual tickets, you can talk about a subscription having a price. You can talk about buying it. It's a thing that you add to an order because you purchase it as one object. And you can talk about adding the tickets in question to somebody's account. It's just that instead of adding a ticket, you're adding 5 or however many the subscription contains. And there are some differences, right? A subscription also has some other responsibilities, like it has to track which tickets it owns, which other tickets it came with. But there's an argument here that you could have most of the operations that apply to single tickets also be meaningful when applied to subscriptions. So in terms of the class diagram notation, we can have a particular kind of component, in this case a ticket, that has some operation on it. If you're a regular instance of that component, the operation just overrides the abstract method. But if you're a subclass that is implementing a collection of components, you can delegate some of the behavior back. And let's see what an example of this might look like. Here's an implementation of how you might do this specific example in terms of models. The overarching class is a ticket, and it's got a subclass regular ticket, which is one of itself, and a subclass multi-ticket, which is a bunch of itself. And you can see that what happens when you, for example, ask about the price of a multi-ticket, all it's really doing is doing a bunch of delegate calls to the price of its individual components, right? So we have an array that tracks the individual tickets that are part of this multi-ticket bundle. And for methods that make sense to call on either the composite or the individual ones, in the composite, we end up delegating to methods in the individual one. So it's nice because from the point of view of the methods that stay the same, like asking about a price or adding it to an order, we don't have to have separate logic in the application, despite the fact that sometimes we're dealing with a single object and other times we're dealing with a collection of those objects. Not all methods will necessarily make sense for the leaf versus the aggregate. So if they start to diverge too much, you might run into this problem of refused bequests, right? Remember we talked about this problem that your superclass is allowing you to inherit methods, but you can't inherit them because they don't make sense for you. That was the case with rectangles and squares. So if you find that the subclasses start diverging a lot, it might turn out that this is not the pattern to use, right? That's sort of a warning sign that it looked like you were just managing a collection of the same object, but in fact the collection is more different from a single object than it is like a single object. So in that case, you don't necessarily do it. Also in this simple example, I didn't put any restrictions on nesting, right? So if you kind of work your way through the logic in these, you can see that if you nested one collection inside another, these methods would all still work, as long as the recursion bottoms out eventually. That may or may not be what you want, but you could certainly special case that out. But nonetheless, this is kind of a very basic version of how you might do this. In fact, we can also use Ruby's open classes so that if we want to override methods like add on to the end of a collection, the double less than method, we can override those to do the right thing. So for example, if a subscription is a kind of multi-ticket, we can override the collection operator to mean the same thing as add tickets, which is a method that we already defined when we wrote our composite class. And then when we're talking about adding a ticket to a customer, this method will do the right thing whether the new ticket is a single one or whether it's a collection of tickets. So again, what is it you're trying to do? You're trying to minimize the number of distinct code paths you have to maintain because that minimizes the cost of having to make a change somewhere. You might be surprised to know that there's a very nice mechanism available in Rails for handling this because it's a common pattern. It's called single table inheritance, and you can Google it. There's a lot of documentation on it. But the basic idea is that if you have objects of different subclasses that are much more alike than they are different, and remember that if you're using subclasses, that ought to be the case, there's a way that you can store those objects in the same table and have Rails automatically manage one of the table columns that says what subclass the object belongs to. So when you pull an object out of that table, it will emerge as an object of the correct subclass. And when you save an object into that table, it will set the column so that it knows which subclass it belongs to. So for example, in our case, we could have ticket as the main active record base class. That's what the database table would be called. But when we create these subclasses, there will end up being a column in the database table that will take on one of these three values, depending on which subclass each object belongs to. So that allows us to implement things like the composite pattern pretty nicely, while still having a single database table, not having to manage multiple tables for the subclasses. So here's a question about the composite pattern in rotten potatoes, which you're probably all sick of by now. But which of the following would be reasonable uses, if any, for the composite pattern? Organizing movies into playlists, or organizing moviegoers into groups in the social networking sense of a group. So only A, only B, both of them, or neither. Which would be reasonable uses of composite?